Linear Algebra for Data Science. In this course, you will build a deep understanding of linear algebra, starting from the basics and going step by step to more advanced topics. You will also see how abstract concepts are applied to real data science problems. Section 2. Orthogonal sets and bases. This section will cover orthogonal set and orthonormal set, orthogonal basis and orthonormal basis, and why are these concepts useful. So, what is an orthogonal set? An orthogonal set of vectors is a collection of vectors in which each pair of different vectors is orthogonal to each other. In simpler terms, this means that the inner product of any two distinct vectors in the set is zero. The formal definition of an orthogonal set can be described in this way. Let's see an example of an orthogonal set. Let's consider the vectors v1, v2, and v3 in R3. These vectors form an orthogonal set because the inner product of every pair of distinct vectors is zero. In addition to being orthogonal, if all vectors in the set have a length of 1, the set is called an orthonormal set. This means that each vector is not only perpendicular to the others, but also a unit vector. Let's see an example of an orthonormal set. Let's consider the vectors v1 and v2 in R2. First, check orthogonality by computing the inner product. It is 0, so these two vectors are orthogonal. Second, check normalization. Both vectors are unit vectors. Since both conditions are met, v1, v2 are an orthonormal set. Next, we will discuss orthogonal basis, but before diving into the concept, let's recap the concept of basis. A basis of a vector space V is a set of vectors in V that is both linearly independent and spans the entire space V. A set of vectors is linearly independent if no vector in the set can be written as a linear combination of the others. A set of vectors spans a vector space V if any vector in V can be expressed as a linear combination of these vectors. An orthogonal basis for a vector space is a basis in which all vectors are orthogonal to each other. An orthonormal basis is an orthogonal basis where all vectors have a norm of 1. Let's see examples of orthogonal bases. An orthogonal basis is a set of vectors where all pairs of vectors are orthogonal, so their inner product is 0. Consider two vectors, v1 and v2, in a two-dimensional space. These vectors form an orthogonal basis because their inner product is 0. In a case of a three-dimensional space, these vectors are orthogonal to each other because the inner product of any pair is 0. An orthonormal basis is an orthogonal basis where each vector has been normalized to have a length of 1. Consider two vectors, v1 and v2, in a two-dimensional space. This set is both orthogonal and orthonormal because the inner product between the vectors is 0. And the magnitude of each vector is 1. In a case of a three-dimensional space, this set is also orthonormal because the inner product between the vectors is 0. and magnitude of each vector is 1. Let's see an example of non-orthonormal basis. Let's consider two vectors, v1 and v2, in a two-dimensional space. These vectors form an orthogonal basis because their inner product is 0. However, they are not orthonormal because their magnitude is not 1. To make them orthonormal, normalize them by dividing each vector by its magnitude. To understand the usefulness of orthogonal basis, let's consider a three-dimensional vector v and demonstrate how the norm calculation simplified in an orthogonal basis. Suppose this vector v can be expressed as a set of basis vectors u1, u2, and u3. And this is an orthogonal basis we will use here. This basis is orthogonal because the inner product of any two distinct vectors is 0. To isolate C1, take the inner product of both sides of the equation with U1. The inner product is linear, so you can distribute it over the terms. In an orthogonal basis, the inner product of any two distinct basis vectors is 0. Thus, all terms except the one involving u1 vanish. So, we can simply express c1 by this fraction. Similarly, we can obtain c2 and c3 as these fractions. Now, let's calculate the norm of the vector v. It is expressed by this equation. Let's expand this equation. In an orthogonal basis, the inner product of any two distinct basis vectors is 0. So, the cross terms vanish, and we can simplify this expression in this way. If the basis is orthonormal, the inner product of each basis vector with itself is 1. So, if the basis is orthonormal, we can further simplify the expression. Orthogonal set is a collection of vectors in which each pair of different vectors is orthogonal to each other. The inner product of any two distinct vectors in the set is 0. If, in addition to being orthogonal, all vectors in the set have a length of 1, the set is called an orthonormal set. These properties can be expanded to basis. And these properties contribute to simplifying computation in various applications in data science. In the next section, we will explore the Gram-Schmidt process, a method for converting a set of vectors into an orthogonal or orthonormal set, further enhancing our ability to work with these essential tools in linear algebra. Thank you for watching. Please thumbs up and subscribe to my channel.